It is time for the periodic table. So we have done atoms, we have done isotopes, we have done protons, neutrons, electrons. So how are all these different elements organized? So this is where the periodic table comes in. So uh, before we begin, a quick recap. The protons, the neutrons, and electrons are the three subatomic particles. The protons, who are in the nucleus, the center of the atom, have a positive charge right there. And they are accompanied by neutrons who have no charge and they hang out right next to the proton in the nucleus. Okay? The last part is that the electrons, which have a negative charge, orbit around the nucleus in different types of patterns, which we haven't learned those patterns yet, but no worries. The other thing is that elements are atoms and they're defined by how many protons they have. So if you're a hydrogen atom, you have one proton. If you're a helium atom, you have two protons. If you're lithium, you have three, and so on. And this is very important because our current periodic table is organized in order of increasing number of protons. So before we get to that, the first periodic table was organized in 1869 by this stone cold fox by the name of Dmitry Mendeleev. He organized his table a little bit differently, and his table is actually in the background of this slide. You'll notice that it's in Latin. He organized it in order of increasing atomic mass, which would be the bottom number of the squares of each element in the periodic table. So if this is nitrogen, that's my atomic number, which is number of protons. Well, he didn't organize it like that. He organized it in order of increasing average mass. Okay? The problem with that is that with mass, sometimes you get two elements that have conflicting average masses. So, like, let's say the one that comes after nitrogen, which would be oxygen, has a lower average atomic mass. Okay? Now, back in 1869, we didn't know how many isotopes there were of each element. We had less information. And so back then, we might have thought that nitrogen might have had maybe a higher atomic mass than oxygen. Maybe back then we thought oxygen was like 15.7. We thought that nitrogen might have been 15.9, okay? Which would put it over here. Now, this specific example is not entirely accurate with these two elements. I'm just giving a hypothetical situation. But nowadays, with more isotopes that we've found since 1869, we know that organizing it in order of increasing number of protons is a better way to do it. So that's Mendeleev. He has a hypnotic gaze. Be careful how long you look into his eyes. Okay, now moving on. How the periodic table is organized is it's laid out like a grid. Okay, you have columns, boom, boom, boom. Columns go down. You also have rows that cross the columns. Boom. Rows go sideways. Okay. Now each row, which goes sideways, is called a period. So the periods go left to right. The columns, which go vertical, are called groups. Okay. And groups go top to bottom. Now, the next thing is that certain groups, ones that are very, very well known and typically used, are called families. Okay, so if you ever see the word family, it is synonymous with group. Okay, so elements are in the same period, which means same row, or they're in the same group, column, because they have certain characteristics in common. And so if they're in the same period, if they're in the same row, they got something in common with the elements next to them. If they're in the same group, they have something in common with the elements beneath and above them. So we'll get to exactly what that means. So this is just a review of what I just said, how the periods, which are horizontal, are highlighted. This example is the fourth period, okay? Meaning it goes that way. Now the fourth period has an orange highlighted around it. And we know it's the fourth period because if I go up to hydrogen, this is the first top row of of the periodic table. So that would be period 1. The next one would be period 2, period 3, and so on. And so you'll see on the side each number of period, which applies to the row that goes to the right, okay? Now if I go down, I'll see that I have 7 rows stacked on top of each other. So that means I have 7 periods that go that way, okay? When I get down to the lanthanide and the actinide series that hangs down below the periodic table, would I call that period 8 and 9? No, I do not. Let me explain why. If you notice that this starts with 57, lanthanum, and actinium starts with 89, okay? This goes there, this goes there. So the real periodic table is much wider than you currently see it. The real periodic table would have these first 2 groups, and then would drop down, and then you'd have this guy right there, sandwiched in between this rest of the periodic table. So then you go to the big yellow block, which has a name, but I'll get to that. Then we get to the non-metals, and then we have helium right there. Okay, so the real periodic table is really long. So why did I bring these guys down? Well, it's because that this sucker is so long that there's no way I'd be able to fit it on a poster in a classroom. That's the actual reason. And so for convenience, we've taken the 2 series and brought them down below right here. So what am I getting at with all this? Okay, the thing about this is that because they are normally supposed to be sandwiched between this big yellow block of elements right here and these 2 groups right here, that means that these fit into the 6th period and the 7th period. So what you can do is when I give you your first periodic table, you can write a 6 here, and a 7, since they fit right in. Now, what about the groups, okay, the vertical columns? So the vertical columns, okay, are organized for a different reason, but they're no less simple to navigate. So you'll see that we have 3 pieces of information. We got a 1, we have a IA, and we have a 1A. So what does that mean? Okay, well the I is actually a Roman numeral, because you'll see 2 I's down here, which is Roman numeral for 2. So it's symbolic of 2. All you need to know is that we need to put a big 1 here. So this is the first group. This is group 2. And then, well, what about these? Is this group 3, 4, 5, and 6, and 7? Well, kind of. But for sake of 8th grade science, this block of elements, we're not actually going to label them 3, 4, 5, 6, and 7. We're going to skip them and move over to here. I'll explain why in a bit. This is going to be our 3rd group. Okay, so this is group 3. So again, you skip these guys. You go 1, 2, and then skip over for 3, 4, 5, 6, 7, and 8. Okay? So you have 8 groups here, and you have 7 periods going down. And again, remember that the group, as highlighted in this black line, is a vertical column. It goes up to down, okay? It doesn't go left to right. Some people still manage to confuse that, and I'm not really sure how, but I don't want you to do that. So, moving on, you'll see, by the way, that I put more reactive and less stable and all that. Don't worry about that just yet, okay? So, why are they in the same row? We said that if they're in the same row, they got something in common with the elements next to them. The periods of the rows. Well, so to this point, we've had our bean exercises with protons and neutrons. So I'll have you put some beans and then put some other beans, okay? And then I had you put your electrons kind of in a ring around it, right? So that's a little inaccurate. The real way that atoms have beans or electrons going around them is that they go in different layers or subshells. So you'll see here that electrons can be on this level, they can be on this level, and they can be on this level, okay? So that means that this atom has not 1 or 2, but 3 subshells that electrons can be distributed on, okay? So if I have 3 layers where electrons can be put onto, that means I'm going to be in the third period or the third row. So I find this atom by organizing it and putting it in the third period, which would be right there. Okay? So that means it belongs in this row of the periodic table. So, well, what do I do next? Okay, let's do a little practice. So, what does it mean if I'm in period 1? Okay, so I go that way. Well, if you're in this period, that means you have your nucleus, and then you have that N stands for nucleus, and then that means you can only have one layer where an electron can be. Okay, the same goes for helium. You can only have one layer, so there's the nucleus, where you have an electron or two. Okay, so as you go down, let's say this guy. Okay, francium is in period 7. So that means that you have your nucleus, this little green dot, okay, and that means you can have 1, 2, 3, 4, 5, 6, and 7 layers where you can put electrons on, okay? So that's all that means. Any element in that period, so the one next to it, okay, the one next to that, the one next to that, all have 7 layers where you can put electrons. It's that simple. And these layers, again, are called subshells. So if you see me talk about subshell, then that means that that's the number of layers that you have. Okay, the groups have something else. Okay, they have something called valence electrons. So what do I do about this? Well, the valence electrons have a certain number of electrons on the outermost subshell of an atom. So first of all, let's practice. This guy's got one subshell. So what period would he be in? Well, he would be in period 1. That's helium. Neon has 2 subshells, so it would be in the second row or period. Okay, argon has 3, so it's in the third period. Now, what am I getting at? We just talked about periods, so what about the groups that go vertical? How many? I'm going to skip helium now because it's an oddball. But if I go to neon, I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, that means it should be in the 8th column on the periodic table. Okay, so right there. And if we look up and we go down to a blank periodic table, neon is in the 8th group. Okay, here's the 8th group, there's neon. That means it has 8 electrons on its outermost subshell. Okay, now argon, how many does argon have? 1, 2, 3, 4, 5, 6, 7, 8. It has 8. Is argon in the 8th subshell? Yes, it is. It's right here in the same group. And so is krypton. Okay, so anybody in this group right here is going to, and it's longer than that, okay, is going to have 8 electrons in its outermost shell. And its outermost shell is called the valence shell. Okay, so let me give you a visual of what the valence shell is. Only this shell, the outside shell, is the valence shell. That's why we call them valence electrons. It's because that's how many electrons you have in the valence shell. That is the valence shell of this one. That is the valence shell of this one. That is the valence shell of helium. Okay. Well, what am I getting at? So wait a minute. There's a problem here. Because all these guys have 8, and they're in group A. But helium, how many dots does helium have? How many electrons does it have in its valence shell? It only has 2, so why is it in group 8? Well, there's a little rule. And if you don't understand this on day 1, that's okay. But the rule is that on your first level, your first subshell, you can only fit a maximum of 2 electrons. So the other part about this rule is that if you look at all the other valence shells, anything outside of the first one, so the second, the third, okay, the fourth one, you can put as many as 8. The max beyond the first subshell is 8. So it's put in group 8 because it's filled up its only shell that it has. Whereas these other guys have done the same thing. They can just hold more than 2 electrons in it, which would be 8, because they have more than one subshell. Now, if you don't get that, that's totally normal. Okay, and this is a little tricky to do through not quarantine, but from remote learning. Okay, from e-learning. But that's what's going on here. So that's why they're organized. So let's do a little practice. Okay, what about? And I'm going to cut off shortly. What about this guy? Okay, if I'm in that group, how many valence electrons should I have? Well, we said this was not group 1 or 2, but this is group 3. So that means that in your outermost subshell, okay, so here's boron's nucleus. In your outermost subshell, you're going to expect to find 3 electrons, okay? Carbon is going to have 4 electrons in its outermost subshell. So carbon would look like this, okay? Nitrogen would have 5, so it would have 5 in its subshell. Oxygen would have 6, so you'd add a 6th one for oxygen. Fluorine would have 7, add a 7th for fluorine, and then all the other guys, except helium, have 8, okay? So that's it. So we're going to stop there for the periodic table, and then I'm going to give you a little practice to complete at home, and that's it.